Welcome back to another video of Dylan Hacks. In this video, I just got the new oscilloscope from China. As you can see, I'm unboxing pretty fast because the box time lapse. Anyway, so this is quite unique oscilloscope. As you can see, it's quite big and pretty heavy, so it's shipped into this large box. And just, we put this box aside. And this is the oscilloscope, the Yokogawa DL1740E. So let's power it on. Okay, here we go. So this is the beast that I'm talking about, DL1740E. So the reason I want this one is because of this vertical kind of form factor, compared to my LaCroix. It's quite different, and this is pretty unique, so that's why I go with this one. It got 1 gigasample per second, but if you're running across all 4 channels, it will be only 500 megasample, but you got analog bandwidth of 500 megahertz, so pretty good. Okay, so what happened here is that, as you can see, that there's this kind of like a jog shuttle knob which is missing, and I'm currently working on it to 3D print. Also, this knob is missing, but we still have this one, so yeah, we can technically, yeah, please focus. Okay, so we can technically model from this knob, and then we can try to 3D print it. Okay, we can put this back. Okay, so let me do some setup and try to power this thing on and see what happens. Okay, so I plug this thing in. Let's see what happens if I turn this on. Oops. Okay, so we have like a welcome screen. Actually, I noticed that the BNC is facing down a little bit. I just have to tilt it. Okay, so we got the first problem here. So I translated it, and it is something like related to calibration data, something like that. Okay, so we definitely got something in the channel. Okay, so it's start off in a row mode, I think. So let me just so we have set up. Okay, so first thing first, I think I'm try to change the language. Okay, great. Okay, so let me go to setup. We have vertical, of course, and we have trigger. So okay, so we select the channels, and we have trigger mode. So I think we are auto triggering right now, and we have like a position start stop, and the button not that good. Okay, so we seem to have some thing. Okay, so we seem to have some sort of signal coupling into this. So let me try to auto setup. Let's see what we got. Okay, this look, I don't know, so crazy. We got like 1 kilovolt per division. So here we can set to 50 ohm. Yeah, we can set to 1 meg ohm, and let me just set to like all of this, just set to 1-to-1 probe. Okay, and on each channel, of course, we have like offset. There was some that on millivolt level, and all is on the full bandwidth. So right now I'm going like crazy. 100 gigasample per second. That is something like what they call, I don't know, equivalent sampling mode, I guess. So we have acquisition, and we can set memory record length. Here we can use the jog knob. Yeah, we got up to 1 million. I think I have to check that. Actually, I think maybe go to um, miscellaneous. I think we have calibration. This is self-calibration. Okay, self-calibration error. Okay, something. Okay, so I take these things apart, and as you can see, this thing is quite large. This, I would say that there's like a lot of dust. So right now I am in the process of taking this thing apart, and here we have some several main boards. That one right there is main board with the CPU, and this one is I think it's an acquisition board, and one under that is the memory, acquisition memory. But I want to show you this, but let me clean this up first because it got a lot of, you know, yeah. And this is the case and some the floppy disk drive and the front panels and everything. So I think it's 9 p.m. right now, so I think it will be tomorrow that I clean this up. Okay, so I put everything, I mean most of the thing back together. As you can see, there's still something that missing, like the front panel, the floppy disk, and yeah. So as you can see, I take one module out, the analog front-end module. I take this one out, and I will show you what happened when I take that one out compared to the one that's seated in it. So let's just wait this thing to boot up. So I hand free right now because my tripod is too high. Okay, so yeah, we still got the blah 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 calibration failure. Okay, so that looks crazy. So let me change time per division. Okay, you remember this frequency? 35 hertz. Alright, so I just tilt the scope on the side, and we have another scope ready. Also the probe that we're gonna use to probe things. So let me turn this thing on. Oh, forgot to flip. Okay, so it's booting up, as you can see. Here we have the screen. Okay, so let's check the voltage. So let's go just sleep. So here you have two capacitors, one on the top and one in the bottom. So one on the top here is the 5-volt positive rail. So if you take a look at my oscilloscope, just focus please. It's showing up 5-volt pretty steady, but if we probed on another capacitor here, which is the negative voltage rail, look what we got. And remember that, 35 hertz. Yeah, so we have some sort of ripple here on the supply, on the negative supply. So it's either something wrong with the power supply, or something on this board is doing some weird things, and maybe the power supply is hiccuping. So one thing I can try is I can try to disconnect this part maybe, and then measure the voltage directly without this board, and let's see what if we can get anything out of it. Okay, so I found something when using my multimeter to probe the resistance between voltage rail and the ground. So let's first off take a look at the 5 volt. So this is 5 volt. It's around 1.2k. So the impedance, total impedance of the system on this, resistance, is about 1.2k. And if we take a look at this one, okay, let me probe on this side first. So this is the negative. That's weird. Let me check again. I have to get some light so I can see it clearly. So this is for reference, this is ground. Okay, and we have this here running, and as you can see I disconnected the power supply. This part running from supposedly a power supply, which is getting to this decoupling capacitor. Let me get this closer so you can see it easier. So on this side obviously it's gonna be ground, so you see very low impedance, and on this side is gonna be the power itself. As you can see, the reading is about 3.6 ohm, which in my humble opinion I think the impedance is way too low for the negative supply. Most of the time negative supply just don't need a bunch of current, so it could mean that something here is shorted. It could be funny if this capacitor is shorted. And right now I don't have thermal camera with me, I left it at my office, so maybe back on Monday I will be able to use that to kind of diagnose and to see what, like some part that heats up that related to negative voltage rail. That would be like easier to identify with thermal camera, hopefully. So let's skip to Monday. Okay, so this is not Monday, and I already bring the thermal camera here, and I already bring it back to my office, and I've been busy working overtime for several weeks. So I finally get back to this thing, and actually the OCP issue from the power supply, it turns out the power supply working just fine, but there is 4 chips that caused this problem. So it's like one of these. I'm not sure if you can see it. It's pretty small. So it's one of these chips. So this is the Yokogawa custom ASIC IC, whatever. This is a A6236LG, so which is it's a competitor IC that we use for triggering on the signal. So it turns out that this board seems to be internally damaged, and it's kind of like shorting. And don't want to say it's short, but it has like very low impedance between negative 5 volt rail and other, I think 3.3 voltage rail. So it's kind of like the current flowing like crazy, and I have to like remove 4 of these chips because all of them getting really hot. It's talking about something like 120, almost 130 degrees Celsius. So what I did is that I was able to track down and source these chips from China, and each one of these cost about 20 bucks, which is pretty pricey. But if it's worth, it's gonna be a pretty good investment into fixing this oscilloscope. And as you can see, I bought 4 of them, but one of them is already populated into the scope, and I'm gonna try to turn on, and I put on the channel too. So I'm gonna see if we can get trigger on channel 2, and let's see if I'm gonna turn it on now. That's on the back. Okay, so the scope boosts up. Okay, so see, we put on 1x, okay, 10x, never mind. So let's turn this thing up. Okay, so okay, we got signal, and let me change the probe setting, sorry, to 10x. Okay, and I'm gonna change the trigger to channel 2. So let's see what happens if we bring this. Hey, look at that. Okay, great. So we got signal triggering, which means that this chip is working. So what I'm gonna do next is I'm gonna put like all of them into the scope, and let's see what happens. So I put all the chips into the scope. As you can see, we are out of this chip, and it's already inside here. And I just turn my soldering iron on for just to be sure if something wrong, maybe I can do some little touch up. But so I plug this thing in, and let's turn it on and let's see what happened. So I put all channels in and hope for the best. So it turns on. Okay, we still have some calibration failure. So sorry. So let's go to the calibration. Okay, so it seems that we still have something wrong here. We still have something wrong, but Okay, so at least we put the trigger chip in, and let's see what we got. So there were some channel that Gonski. So first, yeah, channel 2, we already have channel 2, so let's try on channel 4 because see something that we can still see, and we change to channel 4 and the trigger is working. So it's, and oh, okay, not sure what happened. It's a little bit weird. Maybe need to raise the level a little bit. Okay, seems to be stable, but we saw some, weird things going on. And of course on channel 3, we still have some crazy things going on. We have like a Gal coupling, it's got something like crazy offset. Okay, so I think we need to work on that. But at least we have, yeah, channel 2's trigger seems to be okay. So what I'm going to do here is that I'm going to put heatsink on all of these trigger chips because I think it's going to get pretty hot. So after I do that, I'm going to come back to the calibration error again and see what actually happened. So I just replaced the op amp, the NJM4885, which in the section area that used for, I think, calibration. And as you can see, I partially put some part back and put on all 4 channels, and let's see if we still fail calibration. We'll turn switch on the back and switch on the front. Hopefully we can solve the calibration issue. Okay, so we still have calibration issue for some reason. So let me rerun it again. That's not good, but let's take a look here. Meter reset. It seems like on the first channel, second channel, and fourth channel looks okay now. See, let me crank it up. Okay, the offset looks okay. And let me change to full bandwidth, and the offset looks, we go all the way on all channel, except now on channel 3 that we still have a problem with the offset. So we still have some offset on channel 3, which just means that at least we get some channel backs. We saw some crazy stuff. So maybe they have to flip this thing up again and take a look what happened underneath. And let's see what I've got. Look at that. For some reason the channel 3 looks okay, but I still see like occasional funny things, as you can see. And I try to run calibration, and for some reason it passed, and it's quite unstable. So next thing I can do is that I can try to, swap this to another front-end module and see if this follows. And yes, pretty normal for the MLCC capacitor. But okay, so yeah, maybe I'll try to swap the channel and see what happens next. So funny thing, I don't even need to swap the channel. For some reason, the calibration just passed. So I think maybe because of the solder joints, so I maybe need to touch up it again, because I saw some solder joint doesn't look quite good. But we seem to have another problem with the battery. The backup battery is flat. So yeah, I'm gonna keep that later, because we already decided. I think we fixed it. So I think one thing left for this is just to replace this knob, I mean the encoder, and I think we're good to go. Okay, so I put everything back together. Let's turn it on. Then I replaced the knob, and it took quite a while actually, and I just ran out of space on my SD card. So hopefully that we still have some space left to. I did delete some footages. Okay, we no longer have the calibration error, and let's see what we have here. So first channel, okay, we got a nice trigger. Let's move on the second channel, and we can change. Yeah, we can use this now. Okay, and we got trigger on the third channel, and we got trigger also, and on the last channel, and we also got the trigger. So yes, I think winner chicken dinner for this repair. So I'm gonna put everything back together. For now, for the battery, I just left it there. I'm not worried about that. So let's put everything back together. Okay, so this is it. Everything assembled, the entire scope, and as you can see, it's working perfectly, and minus the encoder that janky a little bit. And all four channel is working, and let's see if we have like auto setup. Here we go. We got all four channel workings, and I also got this thing working. As you can see, with something. Let me try to, yeah, the encoder is working. It's working perfectly fine, and yeah, so it's a big win for the repair. So thank you guys for watching this video. I hope you enjoyed it, and see you on the next video. Bye bye.